Hi, good afternoon, everyone. Myself, Mounika. I'm from the Department of Data Science. I'm working as assistant professor in Mlritm. So today we're going to discuss about understanding learning systems in machine learning. So these are the list of topics we're going to see today. The first one will be learning systems in machine learning. What are the different types of components in learning system, and what are the key steps in designing a learning system? So these three topics will get covered in this session. So first we'll learn about what is the learning system in machine learning. A learning system in the machine learning, which is refers to a structured framework that enables machines to learn from the data and recognize the patterns and make informed decisions with the minimal human guidance. And these systems are the core of artificial intelligence and allowing models to adapt and improve as they process more data. So they consist of input data and learning algorithms and feedback mechanism to refine the predictions. And these systems enable automated decision making and predictive analysis. So let's see what are the different kinds of components we have in learning system. The first one will be data input. So we'll take the raw data or a pre-processed data which will be fed to the system and which will be serves as a foundation of training model. So here we'll maintain the quality of data and the quantity of data and significantly impact the system's performance. And next, coming to learning algorithm. So the core engine that drives the learning process, and the algorithm is like linear regression and neural network decision trees are tailored to solve the specific problems and optimize model performance. So first we'll take the data as input and we'll maintain the data quality and the quantity of the data first, and the next step would be learning algorithm. So to solve any kind of problem, first we'll choose one algorithm from the machine learning algorithm. So here we have list of algorithms like linear regression, neural networks, and decision tree. So these are the algorithm which will be used in machine learning. And next, model output. So once the training is done, the system will start generating the predictions and the classifications and the recommendations, so which are given based on the input data, and that output is continuously refined through the iterative learning. And the last one will be feedback mechanism. So it is a critical component ensuring that the improvement and the feedback compares with the prediction with the actual result and helping the system to adjust and reduce errors. And this is an iterative loop enables the model to adapt and learn. So first we are go with the model output. So just we'll give some model input to the system and the system will predict the outcome. If it is the generated output is matching with the actual output, then well and good. If it is not getting matched with the output, then we'll take the feedback from the model and we'll refine the system again and we'll do some modification and again we'll give the input, and this is a kind of iterative loop until and unless we will reach the actual output as a predicted output. The learning process will goes. And next, key steps in designing learning system. So learning system will involve in some 9 different steps. So we'll discuss one by one. So designing a learning system in machine learning is a multi-step process that ensure the system is effective, efficient, and adaptable to the real world challenges. And each stage builds on the one to create the robust framework. So in this 9 step, each and every step makes a key role in the learning process. So like we have 9 different steps. The first one will be defining the problem and the objectives, and the second one will be data collection and the preparation, and the third one will be the choosing the training experience, and fourth one will be the selecting the target function, and the fifth choosing a representation for the target function, and next selecting the function approximation algorithm, and seventh training the model, and eighth evaluating the model performance, and last iterative refinement. So these are the 9 steps will get involved in learning system. So we'll start with the step 1, that is defining the problem and objectives. So the foundation of a learning system begin with a clear problem statement first. Start by identifying the type of task the system aims to solve, such as classification and clustering. So like first we'll define the problem statement, then we'll choose one particular algorithm to solve that particular problem. Alongside the task, we'll define the measurable performance objectives using the metrics like accuracy, precision, recall, and F1 score. So these are some objectives where we define the types of objective which are involved in that particular task, and these metrics act as a benchmark to access the system success and align its outcomes with the organizational goals. And step 2, so this is a major step, the data collection and the preparation. So data is the backbone of any learning system, and collecting and pre-processing high quality and relevant data is critical for the system success. So why data is important? Like, we are giving any kind of false data to the system, the model will get trained on that particular data and will give all the false prediction. So that data will be considered as a backbone for the learning system. So we need to maintain the quality data and the quantity data for the training purpose. So first step in this, the subsection will be data gathering. So we'll collect the data from the different sources. So data can be come from the databases, APIs, and the real-time sensor. For instance, the financial forecasting may rely on stock market data, and while medical systems can use the patient record. So every time data will get gathered from the related databases or the applications. And the second one will be data pre-processing. So basically, whatever the data we are collected, that will never used as a training data. First, we'll clean the data and we'll set some quality data for the learning purpose. Further, we need to do the data processing step. So here, the raw data often contains inconsistencies and the missing values and the outliers, and we'll use some kind of techniques to handle the missing values and the normalization. And the data cleaning ensures that the data set is ready for the training, and which has the minimizing errors caused by the poor quality data. So data will get gathered and we'll clean the data by using some pre-processing tests. Once the data is getting clean, then we'll use that particular quality data for the training purpose. And step 3, choosing the training experience. So deciding on the training experience based on the problem and nature of the data. So basically, in the machine learning, we have 3 different kinds of algorithms for supervised and unsupervised and the reinforcement learning. So based on the problem type, we'll choose one of these 3 algorithms. So first, supervised learning. So this is best for the task where labeled data is available. So here, supervised learning algorithm will come with the labeled data, and such as predicting loan defaults. So unsupervised learning suitable for uncovering hidden patterns for unlabeled data. So basically, unsupervised learning come with the unlabeled data, and which is used for clustering the customers. And last one will be reinforcement learning. So this is ideal for dynamic environment like robotics or a game where the system learn through the trial and error. So reinforcement learning basically is a feedback based learning where we'll do some n number of trials and we'll get some errors, again we'll rectify those errors. So like that, we'll completely work on feedback based mechanism. And step 4, selecting the target function. So that target function defines the relationship between the input and the output. So basically, we'll have some features as the input and we have predictions as the output here. So first, we need to select the target function. For instance, a target function for a loan approval model might map the customer income and the credit history to a binary decision, approve or delay. So the target function has been decided based on certain conditions. Let's say like we are going for any kind of loan. First, they will check for the customer income and the credit history. So based on that, the a particular candidate is eligible for the loan. So like that, we'll check for the criteria so that we can approve for the loan or we can deny for the loan. And clearly defining this function ensures that the algorithm focuses on the right outcomes during the training. And step 5, choosing a representation for the target function. So choosing an appropriate representation for the target function depends upon the problem complexity and the data characteristics. So let's see the different kinds of representation for the target function: decision trees and neural networks and the linear models. So these are the example representations which will be used in machine learning. So decision trees, which is effective for hierarchical decision making task. So basically, decision trees will be used with the hierarchical data. And the neural networks, which will come suitable for handling nonlinear relationship in a large and complex data set. And the linear model, So which is the best for interpretable and the straightforward problem. So based on the type of problem, we'll choose one of the representation to go with the training. And this step requires the balancing model complexity with the interpretability and the computational efficiency. Comes further step 6 with selecting a function approximation algorithm. So selecting a learning algorithm that effectively approximate the target function. So choosing algorithm is the best part. Like we have some examples: algorithm, gradient descent algorithm, support vector mission, and the k-means clustering. So gradient descent will be commonly used in training the neural network for minimizing the error. And support vector mission, that is SVM, will be used for classification task basically, which will require the clear decision boundaries. And the next one will be k-means clustering, so which is effective for grouping data points in a unsupervised learning scenarios. And the algorithm choice must align with the problem type and the data characteristics and the performance objects. So based on this, one of the algorithm is getting chosen for the model training. And step 7 comes further training the model. So that training the chosen model is used the prepared data. So basically the training comes with the prepared data. So first the data will get connected, we'll do some pre-processing technique, then we'll choose one algorithm for the model training, then the actual training will get started here. So this involves first step iteratively feeding the data into the algorithm. So whatever the prepared data we have, that will be getting trained into that will be fed to the system first. And adjusting the model parameters and minimizing errors, techniques like backpropagation in neural networks. And next, monitoring the training process to avoid the issues like overfitting, which occurs when the model performs well on training data but poorly on unseen data. So we'll monitor the training process to avoid the issues like overfitting. So overfitting is a concept where the particular model is getting trained on some particular data. When we give any kind of new data other than that prepared data, so it will give some false prediction. So we need to overcome those kind of issues and we need to monitor the model training procedure. And the step 8 comes for evaluating the model performance. Once the training is done, then the evaluation comes into picture. So the evaluating the model ensures it generalizes well to the new data. So we'll use some different techniques to evaluate the model here. So first, validation split, cross validation, and analyze metrics. So these are some factors which will define the model performance. First, validation splits. So dividing the data into training and the validation in the test set. So these are the factors for designing the validation splits. And next comes for the cross validation. So it will use some techniques called k-fold cross validation, which will provide the most robust evaluation by rotating and training the model, and which will test the training data sets. And the last one, analyze metrics. So it will use some task like accuracy of classification task. So how a task is getting classified into certain categories. And next we'll use some mean squared error for the regression problems and ROCAU for the binary classification problem. So based on the problem statement, we'll analyze the metrics for the each model. And this evaluation process identify the weakness in the model and guiding further refinement. So by evaluating the model performance, we'll get to know, and if we found any kind of errors in the model training, then it will go under some refinement. And the step 9 will be the iterative refinement. So refining the model is a continuous process to aim at improving its performance. So if we found any kind of errors while training, once we get any kind of false prediction, then we'll go with the iterative refinement. The first one will be hyperparameter tuning. So we'll adjust the parameters like learning rate and the depth of decision trees or the number of layers in neural network. So these are the parameters will get changed in the refinement to get the accurate performance. And the next one will be retraining with the updated data. So here incorporate with the new data, the additional data to enhance the model understanding of the problem domain. So let's say we have prepared some prepared data, and after some days we are adding some new data to the system, so that the system should get updated with the new data as well as previous data. So at the time we'll retrain and we'll update the data. And the last one will be re-evaluating the performance. Once all the parameters are getting adjusted and if there any updation of data in the like for the training data, then the re-evaluating the performance is getting calculated. So here this can be done with the regularly access of the model by using updated validation data sets to ensure the consistent improvement. So once the refinement is done, then again we'll evaluate the model performance and we'll decide how the model is getting are giving the predictions in a good manner. Thank you.